Hi there and welcome back to the Good Tutor Premier Prep SAT course, and in this video we're going to continue our look at the Passport to Advanced Math subsection of the SAT Math section. And particularly we're going to take a look at rational expressions and equations and introduce you to what each of those are, and then view an example of one as well. Alright, so for an introduction, a rational expression is a fraction with a polynomial in the denominator. I know we've learned about polynomials in the last few videos, while a rational equation contains at least one rational expression. So a couple things to keep in mind about these rational expressions is that factors in a rational expression can be simplified, while individual terms cannot. And what that means, I'll show you an example here, that if you had the two factors like this, let's say x minus 1 over x minus 1, again, those are two of the same factor, which means they could simplify, and you would have that's equal to 1, right? And it would just simplify out like that. However, if you had, like, let's say x minus 1 over x minus 3, and you said, oh, it's x over x, and those can simplify, no, that cannot happen. Because, again, entire factors can be simplified, but individual terms cannot be. So that is not an example of what we can do to simplify a rational expression, right? All right, then the last rule here we have is that if a rational expression has a higher degree in the numerator than the denominator, it can be simplified using polynomial division. And you learned how to do polynomial division in the last video. All right, so if we view an example now, it says if the expression above is equal to negative h over z plus 2 squared, where h is a positive constant and z is equal to negative 2, then what is the value of h? Well, first we know here it says that these two things were equal to each other. So that first part it says was equal to the part provided in the second part of the problem. So if we set that up, we'll have 6z plus 5. And we'll go ahead and combine these steps. And it says that we know that z is equal to negative 2. So wherever we see z is negative 2, then we're going to find that value of, we're going to plug in negative 2 for z, but we don't even have to do that yet. So z plus 2 squared minus 6 over z plus 2 is equal to negative h z plus 2 squared. Now remember, when we deal with any sort of fractions, and not even just ones like these, but even whole number fractions, or fractions that contain whole numbers in the numerator or the denominator, I should say, we always want a common denominator when we are adding or subtracting, right? In this case, we're subtracting. So our common denominator here between z plus 2 squared and z plus 2 would be z plus 2 squared, right? So we need to make sure all these denominators are z plus 2 squared. So right now, two of them are, right? The one all the way to the right is, and the one all the way to the left is. But unfortunately, that one in the middle, that 6 over z plus 2, is not. So we have to ask ourselves, how can we get z plus 2 to be z plus 2 squared? And the answer is multiply that entire term in the middle by z plus 2. And that has to be, of course, both the numerator and the denominator, right? So if we do that, then the first term there will stay the same. So 6z plus 5 over z plus 2 squared. Now we have, okay, so now if we multiplied, ultimately, right, we know the denominator, the whole point of doing that, right, was that the denominator would be the same, or that common denominator of z plus 2 squared. So we have z plus 2, and let me make sure you can tell that that's a z there. Yep, z plus 2 squared is the denominator. And let's see what we have in the numerator now, though, right? Because we had negative 6, which is right there, being distributed to the z and then to that 2 as well. So that would be negative 6z, right? And it would really be, won't even worry about the sign yet. So it would be negative 6z. And then 6 times 2, or that negative 6 times 2 would be minus 12, right? Is equal to, again, just keeping that last one the same, negative h over z plus 2 squared. So from there, I'll actually do the rest of this problem up at the top there. Now we know we have those three common denominators, right? Which means now then the denominators don't really matter because we just wanted to make sure they were all the same. So those don't really matter now. And what is important is what's left in the numerator. So we have 6z plus 5 originally, right? And then minus the 6z minus 12 that we reached is equal to what was left over here, a negative h. So now we just have to combine like terms. And if you look at this, you should see immediately, right, that a positive 6z and a negative 6z will cancel out. And you'll be left with 5, positive 5, and negative 12, which will be negative 7, being equal to, it's left over here, negative h. And then if we multiply both sides by negative 1 to get rid of that negative, you'll find that h is equal to 7. All right, and you can plug that in, of course, and you would find that they are equal to each other as well. So h is equal to 7. All right, that is it for this video, and coming up next, you'll look at solving quadratic equations.